8 of our 90-day mission, and we started climbing up the hills with Spirit. Meanwhile, we spent a lot of time in Eagle Crater, but after a while we looked at it and said, well, let's get out of the crater, let's see what else there is. Shrink down that image, you can see, well, that little crater was exciting, but look off the little ways to the right, not even a kilometer away, there's a really exciting crater. This one's as big as a football field. Let's see what's there. So we drove across the plains. We sent both rovers off on a long drive. Here we are at that crater, the big crater, Endurance Crater. At first we looked at it and said, well, this is a little too steep to drive into. We're not rated for mountain climbing on this rover. But after a while we said, well, if we're careful, we can drive in. Drove into the crater, started looking at some of the weird rocks here. This particular rock over here, let's do this one. In fact, all the rocks had names. The geologists, of course, talk about rocks all the time. So that they know what rock they're talking about, they give all of the rocks names. And usually the first name that they give it sticks. This particular one, the first people looked at it named it Dinosaur Brain. And actually, I guess that was just one step too far. Steve Squires said, hey, look, guys, if you name a rock Dinosaur Brain, somebody in the press is going to pick up that name, and they're going to, go the wrong direction with it, give it another name. So in fact, it ended up named Wapme. And for those of you who want to know what Wapme means, come see me later. So, the mission lasted much longer than we expected. It lasted into the winter, and we survived this first mission by the technique of finding some of these spots that are highly tilted and tilting into the sun. In the winter, solar-powered rovers, sun is kind of lower on the horizon, so we found places where we could tilt, so we tilted into the sun. The rovers were getting a bit dusty. Here's a view looking back. My nice, clean, shiny solar arrays were not so clean and shiny after about a year on Mars. It turns out when spring came on Mars, on the Spirit site, we started seeing the solar arrays mysteriously being cleaned off. One hypothesis was Martians were coming at night when we didn't have the cameras on and cleaning off the solar arrays. As it turned out, the Martians were not coming in the middle of the night mostly. They were coming right in the middle of the daytime, and we could see them. Here are some of these dust devils dancing across the surface of Mars. And dust devils, or other types of wind gusts, happen apparently primarily in the springtime and the summertime when Mars heats up a little bit and makes the atmosphere move. So we got a new lease on life. After a year of dust deposition, our solar arrays were getting pretty dusty. But a little bit of cleaning, we weren't good as new, but we were good to go. We had enough time to survive another summer. So we looked at it and said, well, let's see what there is. Here is the entire Opportunity mission for the first year and a half on Mars. We spent in this little region that's not even a kilometer wide. Landed here, drove across here, went into Eagle Crater. But then we looked at the images and said, well, let's look and see what else there is. This is our mission for the first year. Here's what's down below, and here's our track. So we said, let's drive across the plain, because we thought that was a big crater. But here's a really big crater down at the bottom. Let's gun it. So we gunned it across the plain. Took us a while. We were driving across pretty flat terrain. In fact, there's not much here. What there are these little sand drifts. These sand drifts are about knee-high. They're not very high. There's lots of them. But in the drive, we, in fact, did a lot of atmospheric science. We could see some of the clouds. Mars has 3 different kinds of clouds, unlike Earth. Mars has dust clouds. You can see them from Earth, in fact. They're sort of yellowish clouds visible in a telescope. These are not dust clouds. Mars, the dust devils, however, were dust clouds. You can see what paints the dust devil is Martian surface dust. Mars has carbon dioxide clouds. Sometimes it gets cold enough in the upper atmosphere that the atmosphere itself crystallizes out, and you have clouds of carbon dioxide in the very high atmosphere. But these particular ones are water ice clouds. So when we think of Mars as a dry planet, it's not entirely dry. It does have some water vapor in the atmosphere, and in midwinter we get these high clouds. And we took a couple of images. We took a lot of images of the sun. Here's a nice image of sunset from Gusev crater. In fact, I think I took this image. I took a lot of the sunset images. But here you can see the sun beginning to set over the rim of Gusev crater about 50 miles away. So the atmosphere of Mars is pretty dusty in the summertime. Clears up a lot in the wintertime. Enough so that we can see the sunset off over to Gusev crater. But we did drive down to the big crater. Here's Victoria crater. In fact, if you look carefully, you can see the path. But by this time, we had the good camera in orbit, the nice spy camera. And here is our rover. There's Opportunity, sitting on the rim of that big crater, of Victoria crater. So we came to Victoria crater, and that one really is a big crater. There's our path. The first thing we said is, well, let's drive around and look into the crater and see if there's a good spot to drive in and take some pictures of the cliffs. Turns out, actually, that there was a pretty good spot, and amusingly, it was the very first spot we entered. We decided to call that Duck Bay. Here's just some images of the crater from the edge. Just a quick quiz. Did I tell you there would be a quiz? Here's the quiz. Is this true color or false color image? Or stretched color? Anybody? True? Stretched? Okay, everybody's saying false. Yeah, of course. Look at that bright blue sky. Mars's sky is not bright, sort of blue-pink. Stretched color. So you can see some of the striations. Here's another view. True? False? False color, yeah. Look at that blue soil. But what you can see is a lot of layers of deposition. So what we started learning here is there wasn't just a little sedimentary rock deposited here. There was a lot of sedimentary rock deposited here. Analyzing this rock, we discovered that these were typically magnesium ferrosulfate salts. So on Earth, if you deposit at the bottom of the sea, you'd get a lot of sodium chloride salt, halide. These are ferrosulfates. Actually, it's very similar to gypsum. So we do get chalk cliffs on the Earth. It's much like the White Cliffs of Dover. But actually, it's a mineral called jarosite. The interesting thing about jarosite, this magnesium ferrosulfate, is that on Earth it is deposited in very low pH conditions. So this is not merely the signature of ancient briny oceans or possibly very briny lakes. It's the signature of very acid oceans. Now, we don't know the geochemistry of Mars perfectly. It's possible jarosite deposits under different conditions on Mars. And we know that Mars can't be globally acidic because there's a lot of rocks on Mars that would be weathered away by acid oceans. But at this particular site, we're looking at rock deposition that's very acidic. So that's an interesting data point about the climate and the past history of Mars. And here's our, when you go to Paris, you take your picture. Here I am in front of the Eiffel Tower, and you go to Greece, and here I am in front of the Acropolis. Well, here's our picture. Here we are on top of the cliffs. The image had a little bit of help from Photoshop to show her. But that gives you about the true size. For reference, this is just about 6 feet from the bottom to the top of the rover, about 2 meters. So if you were standing here, you'd be about that high. So it gives you a view of how the size of the craters. On the other side of the planet, we drove to the top of the hill and we looked down and said, well, wow, cool, there's interesting stuff on the other side. So we drove down the hill. We looked at this feature, home plate, turned out to be extremely interesting. We didn't know what it was looking down from the top. Turns out actually it's a tuff ring, so it's a volcanically deposited crater. we did have some problems when we got to the second winter. We were driving like mad, in fact, for the hills in the distance, so we could find a place where we could tilt to the north. But in the third year, actually end of the second year, we had lost one wheel. So our 6-wheel Rovers became 5 wheels plus 1 snowplow. That was hard. It made it hard to drive across sandy soil. It had some advantages. Actually, here's our skid marks. And you can see, well, that wheel is dragging like a snowplow, but it's actually giving us a bit of excavation. So as we drive, we can see what's underneath the soil. And we're seeing some very interesting white salt underneath the soil. So the top few inches of this soil is that red Martian soil, but underneath we're seeing sulfate salt. So we gave up on the idea of driving for the hills. We found a tiny little spot, just a very low ridge. This was about a 10-inch high ridge that we could drive onto and tilt us to the north to survive the second winter on Mars. It turned out to be actually a very exciting spot. Here's our second winter spot, and in some places it had this very platy material. At the end of the second winter, though, we could drive around some more, and we discovered that on that feature, home plate, there was something very interesting right here at the right edge of home plate. This was pretty much the most interesting thing we discovered at the Spirit landing site. So we spent a lot of time driving around in that tiny little valley at the edge of home plate. What was interesting is this. We looked at it, and here's some of that soil that we turned up. But inside that little square with the close-up, we're looking at some material that's sort of very interesting, and it turned out to be highly silicon dioxide, SiO2. And in fact, it's opaline silicon dioxide, although I don't think it's gem quality opal. So for those of you who want to sell Martian jewelry, probably you don't want to go here for Martian opals. But here it is in close up. Silicon dioxide, pure SiO2, is the signature of hot springs. This is an alteration product that we get in places like Yellowstone. You can find rocks much like this at Yellowstone, and you get it when hot water cools down and deposits dissolved silicon dioxide. So what we seem to be looking at here is ancient hot springs on Mars. And it can't be too ancient hot springs on Mars because it would have been buried. So this is a very exciting spot. Well, the third year on Mars, we ran out of luck. The first 2 years on Mars, we had nice, beautiful, clear weather in the summers. Roughly every 3 years on Mars in the summertime, you get a global dust storm, where you get local dust storms pretty much every year. There's lots of local dust storms. We just sort of wait them out. The third year on Mars, however, we got a global dust storm. The atmosphere gets very thick. So here is our horizon image taken a couple of days as the atmosphere gets thicker and thicker. And at this one, it was pretty much too thick to do anything. So we ended up sleeping through the end of summer, the third year of Mars, saying, well, we hope this dust storm goes away or we're going to have real problems. Both rovers pretty much had to just go to sleep. We set Spirit to just call home every 2 days. It would wake up, call home, say, I'm still alive, have any instructions? Nope, go back to sleep. It took about 2 months to wait for that dust storm to clear. However, meanwhile, in January 2008, we celebrated our 4th Earth year on Mars. This was still the end, I think, of the second Martian year. Well, we did survive to the end of the winter, to the end of the dust storm, and we woke up, but unfortunately at the end of that summer dust storm, Spirit was pretty dusty. Here Spirit is now pretty much a camouflaged rover, and winter